In the profundities of space, the James Webb Space Telescope has seen something absolutely stunning. Splendid lights, frightfully suggestive of Earth's clamoring urban areas, radiating from Proxima Centauri b, an exoplanet 7 trillion miles away. Are you prepared to face what lies past the stars? Might we venture to stop and think about what could be possible? Finding a civilization not our own. What mysteries might they at any point hold? And what does this mean for humankind's future? As the world wrestles with the ramifications of this surprising find, the James Webb Telescope's most recent perceptions suggest beyond what simple arbitrary light could. Could these be intentional signs from a high-level civilization on Proxima Centauri b? Each gleam and movement across this massive distance welcomes speculation that we may be near the precarious edge of the most stupendous disclosure in mankind's history. Contact with a different universe. This fragment of space, once thought quiet and ruined, now murmurs of conceivable life. With each piece of information, we inch closer to potentially modifying history. As the telescope investigated the boundlessness of space, it found something interesting on Proxima Centauri b. The far-off exoplanet produced lights that look like those from urban communities on Earth, alluding to the possible presence of an outsider development. This thought has created impressive fervor and interest among researchers. It very well may be the revelation they've been waiting for, highlighting the presence of savvy life forms who may be coordinating their networks in ways we've never envisioned. David Kipping, a cosmologist at Columbia College, depicted the planet where these lights were found as particularly complex. This complexity arises because, unlike most rocky planets that retain daylight and emanate infrared energy, this exoplanet acts differently due to its unique relationship with its star, Proxima Centauri. Yet, this isn't the only amazing aspect. The discovery by the James Webb Space Telescope highlights just how powerful this instrument is. The telescope's capacity to recognize infrared light was key in viewing these surprising lights, showing us how much more there is to gain. The intensity signals from Proxima Centauri b are crucial for understanding what its atmosphere may be like. Researchers need to continue utilizing this telescope to learn more about the planet's atmosphere and to explore if it might actually support life. The James Webb Telescope excels at distinguishing infrared light, which assists it in noticing Proxima Centauri b's evening activities. Many telescopes struggle to detect faint lights in the immense darkness of space, but the James Webb Telescope can catch even the littlest flickers. This makes it ideal for checking if the supposed city lights on Proxima b's dim side are genuine. The telescope can distinguish any artificial lights in space if they emit within a particular narrow frequency that is much better than normal starlight. Proxima Centauri b has a close relationship with its star. On the side facing the star, numerous solar panels would gather energy from the intense sunlight, and its capacity with the dark side would also reflect some light. As Proxima Centauri b circles its star, it experiences a constant cycle, like Earth with hot days and cooler evenings. The planet shows huge temperature contrasts, largely due to its composition. For example, if Proxima Centauri b doesn't have an atmosphere, the temperature difference between day and night would be extreme. Without atmospheric gases or seas to level out these extremes, the day side would become incredibly hot while the evening side would freeze. These sharp temperature contrasts interest cosmologists since they can reveal insights about Proxima Centauri b's climate. With its strong infrared abilities to image, the James Webb Space Telescope can measure the planet's intensity, giving significant hints about its atmosphere. Anyway, the most intriguing part is that the James Webb Telescope's orbit around Earth is aligned with Proxima Centauri b's orbit, permitting it to notice the planet's constant cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the following step is to study its chemistry to see if it could support life. Signs like oxygen, water vapor, and methane could indicate that the planet has conditions suitable for life. Observing these elements on Proxima b would strengthen the case for its ability to support life, leading to detailed measurements and analyses of the light passing through its atmosphere. Yet here is the trick. The James Webb Space Telescope can look at a couple of the closest planets that may be livable. For a broader perspective on many more planets, researchers are eagerly anticipating the Very Large Telescope, ELT, which will start working in 2028. The ELT is expected to provide a clearer picture of what far-off planets' atmospheres are like and how likely they are to support life. Mainstream researchers are looking forward to the new insights that the ELT and other future telescopes will bring. Meanwhile, the James Webb Space Telescope remains a significant tool for studying planets outside our solar system. Even with its limitations, it continues to provide valuable information that could change our understanding of the universe now and in the future. As we dive into the next part, we will further interpret these invigorating discoveries, creeping closer to possibly earth-shattering disclosures. Looking forward, new space telescopes will aim to reduce the bright light from stars, making it easier to see the planets that orbit them. This is like covering your eyes with your hand to see better in bright sunlight. By dimming the starlight, these advanced telescopes will be able to capture the faint glow from distant planets more effectively. This clearer view will assist researchers in studying the atmospheres of these planets and determining whether they could support life. However, this is no simple undertaking. Researchers must carefully distinguish gases produced by living organisms from those resulting from natural processes like volcanic eruptions. They want to fully understand these distant planets so they can accurately identify signs of life and avoid being misled by natural events. The James Webb Space Telescope opens up additional opportunities for future discoveries. As we continue to explore space, we draw closer to understanding more about the vast universe and our place in it. As long as humans have existed, we've pondered whether we are alone in the universe. This question still drives many researchers today. At present, the James Webb Space Telescope is analyzing various planets and moons, looking for signs that life could exist beyond Earth. The possibility that life could exist somewhere else in the universe is gaining popularity, and this growing belief excites many about the chance of finding extraterrestrial life. In 1984, two American cosmologists, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI. They created a non-profit organization to listen for radio transmissions from space, hoping to find something sent by intelligent beings. They use radio waves because these transmissions can travel great distances without losing strength. The Allen Telescope Array in California, which includes 42 radio telescopes, is at the core of their work. Despite the fact that SETI has been listening for more than 30 years, they haven't yet found any obvious indicators of extraterrestrial life. However, Jill Tarter remains hopeful. With the present cutting-edge technology, she believes a major discovery could be just around the corner. She dreams of a global effort to find out if we are alone in the universe. Recently, excitement grew when NASA reported that the James Webb Space Telescope might have spotted something resembling artificial light from a city on a nearby planet. The James Webb Space Telescope, situated 1 million miles from Earth, is significant for space exploration. It sends back detailed data about the oldest pieces of the universe and is specifically designed to capture details we've never seen. This helps us understand how worlds, stars, and planets form. Astronomers are utilizing the James Webb's advanced tools, like its precise camera and unique filters, to study the light from stars and planets. By focusing on specific types of light, the telescope helps researchers determine the physical and chemical makeup of distant worlds. Yet, this isn't the most astonishing part. The James Webb Space Telescope goes beyond simply observing. It actively studies the atmospheres of various planets, searching for even the smallest indications of life. With its unmatched ability to explore the universe, the Webb telescope is leading us into a new era of discovery. Researchers have recently made some enlightening revelations in the universe, finding much more material hidden in vast galaxies than they ever expected. These discoveries are pushing scientists to rethink their ideas about how the universe began and evolved. Each new revelation from the James Webb Space Telescope brings us closer to understanding the farthest reaches of space and what life could exist beyond our planet. With the help of the James Webb Space Telescope, researchers are delving deeper into space than ever before, gathering data on distant worlds that could help answer fundamental questions about these far-off planets. Only 20 years ago, our understanding of planets outside our solar system was minimal, but since then, astronomers have discovered over 4,000 exoplanets orbiting various stars. This demonstrates how powerful our curiosity and technology have become. NASA believes these discoveries are just the beginning. suggesting there could be trillions more exoplanets waiting to be found. As scientists continue their space explorations, they are eager to find out where extraterrestrial life could exist. Sometimes they encounter signals that suggest they are on the right track. For example, the Galileo spacecraft made an incidental discovery near Jupiter that indicated possible vegetation. This was a pivotal moment, marking the first recognition of what is known as a biosignature, specifically the vegetation red edge. This method identifies life by studying how light reflects off it. Now, the James Webb Space Telescope is prepared to delve further into the search for extraterrestrial life, focusing on planets that orbit within the habitable zones around their stars. If these signs of life are confirmed, they could disrupt our understanding of the universe and our place in it. The quest for understanding life beyond Earth has reached extraordinary levels of complexity with the emergence of advanced space telescopes and observational advancements. As astronomers continue to push the limits of what's possible, they are not just investigating the physical properties of distant exoplanets, but also delving into their potential to support life. The technological advancements that have arisen over the past few decades are fundamental to this quest. One notable advancement is the progress in spectroscopy, a method that analyzes the light emitted or absorbed by objects in space. By studying the spectra of light from distant exoplanets, researchers can identify the chemical composition of their atmospheres. This method has already provided significant insights into the atmospheric conditions of several exoplanets, revealing the presence of gases like hydrogen, helium, and carbon dioxide. These discoveries help in assessing whether an exoplanet could have conditions conducive to life. Another exciting avenue is the investigation of exoplanetary weather. Understanding these patterns can provide hints about the atmosphere of distant worlds and their potential habitability. For example, the discovery of seasonal variations in atmospheric conditions could indicate the presence of liquid water, a critical component for life as we know it. Scientists are also examining the potential for extreme weather phenomena, like intense storms or temperature fluctuations, which could impact the habitability of an exoplanet. The search for biosignatures or indicators of life is an area of intense focus. Beyond the conventional search for oxygen and methane, researchers are exploring other potential biosignatures, such as complex organic molecules and unusual atmospheric anomalies. The James Webb Space Telescope, with its advanced spectroscopic capabilities, is well suited for this task, offering the potential to detect these subtle yet significant indicators of life. In addition to direct observation, theoretical models play a vital role in guiding the search for extraterrestrial life. These models help scientists predict what kinds of signs or conditions may be present on exoplanets based on known principles of physics and chemistry. They also assist in designing observations and missions that could test these predictions. For instance, models of exoplanet atmospheres can simulate the potential effects of different gases and environmental conditions, directing future observational strategies. Furthermore, the integration of artificial intelligence, AI, into space exploration is revolutionizing data analysis. AI algorithms are increasingly being used to sift through the vast amounts of data collected by space telescopes and other instruments. These algorithms can identify patterns and anomalies that may be overlooked by human observers, providing new insights into the nature of distant worlds. International collaboration is also playing a crucial role in advancing space exploration. Researchers and scientists from around the globe are working together to share knowledge, resources, and expertise. This collaborative approach enhances the overall understanding of exoplanets and accelerates the pace of discovery. As we look ahead, the continuous improvement of space technology and analytical methods promises to bring us even closer to answering one of humankind's most significant questions. Are we alone in the universe? The ongoing efforts and advancements in this field highlight the remarkable progress we are making in our quest to explore the universe and understand our place within it.